长押四足，破门而开，只见前序半步，一人曾举目，孤行伫立，待得日当正中，等教问句残花乎？低头难辨是非，唯有墨鱼之术，盘中人皆得正夜忽而定闻琴上风骨。生者一寸，一方便言和，一对对正主，有下人无语。红尘飞鸟唯有一人卡夫，对月相恋，和手指相互，都是在无心日出。横听手指点打勾交接变化，笔奏老舍墨书春秋尽潇洒，不见当初前人定道今舟上刻画，烟坠成万岁千载人神话，聊一书笔写遍古今的繁华，书经如变故自将历史传达，你总千年又有谁人能回答？一颗相信花香，对看烟点周沙。下出两天，大到一桌之间，饱食半边。愿我横双眼，坐立周家独根残枝出烟。地上边这般深渊，滚层海底水无存，只剩半杯四间。禁不住抗面无手住下飞开日出期限。闭目静白，为我而立，平衡我山前，长街尽目睹。若是日下竟有狮子沉淀，地下看烟，草人不见，定舍绿雾中头衔。水陆玄真举墨藏锋的正法，书动南北交手相传半天涯。可问谁人流上至谁人听？哇！こんにちは，こんばんは，おはよう，早上好，中午好，晚上好。Good morning, good afternoon, good evening. We are back at this again. Trying to not make our head explode. And I'm gonna start right away into the question. Also, someone commented earlier. Someone commented earlier and said, "You see, Jared, you just loop over the list with 2 copies of the header. 1 copy moved 1 node in the list, and the other moves 2 nodes in the list per loop. There are the slow and fast pointers." Okay, thanks for explaining what I explained. Thank you for explaining what the fast slow pointers are. And who is Jared? Anyway, so we're gonna start right away to the questions. So the fast slow pointers only have 2 challenges lists. 2 challenges left. One of them is hard, so I don't have a good feel about this. Problem challenge 2: rearrange a linked list. Given the head of singly linked list, write a method to modify the linked list such that the nodes from the second half of the linked list are inserted alternatively to the node from the first half in reverse order. So if the linked list has node 1, 2, 3, 4, 5, 6 node, your method should return 1, 6, 2, 5, 3, 4 node. Oh, what the fuck? Oh, what the fuck? Hello, hello. Okay, so this is like the extension of the previous question. I think what we're gonna do is we're gonna use slow and fast pointer to find the middle node. Find the middle node and then split this into half. After we split this into half, we're gonna take the second half and reverse this order. After we reverse this order, we're gonna loop through the first half and the second half at the same time. And for each node here, between these two nodes, we're gonna insert one node from the second half in the reverse order, and then update all the pointers. What's my pointer pointing to in database? There's no database. This is just a coding challenge. Singly linked list. Okay, so that's what I'm gonna do. First thing we're gonna do is we're gonna set a slow and fast pointer, both of them pointing to heads. And while fast is not no, and fast.next is non-no. Then we're gonna do fast.next. Fast equal to fast.next, and then slow equal to slow.next. And by the time the fast hits no, because this moves two nodes ahead and slow moves one node ahead, so the fast will hit the nodes when the slow is halfway. So by the time this exits, slow will be at the middle node of the linked list. So next we wanna do is we're gonna reverse. Okay, we're doing this again, which makes my head hurts. Okay, we're gonna reverse. We're gonna reverse the second half. And the way we do that is, so we're gonna set a placeholder called previous, and we're gonna have the previous equal to no, while head is no. We're gonna have a placeholder called next, and then place head on next into next. And then we need to set so we need to reverse this order, right? Reverse this order because it's single linked list. It's a single linked list, so the second half will always start from 4, 5, 6. Right? We set the previous as a no. So we need to update 4 to no. Right? Head.next is gonna equal to previous. Actually no, head.next should be equal to 4, 5, 6. Because then we want the new head to be 5. So head should be now. Head is previous. I want to store head to something else. Hold on. Previous should be head now. And head is next. Head is the next one, and previous is the current one. And previous is the current one. And where should head on next then? Like, head on next should be head is next. Okay, this confused me a lot. So 4, 5, 6. We want to do a no here. Cause right now it's like this. Right? Right now it's no. And we want to reverse its order. So we set previous as no. So heads. So head down next should be previous. Actually, you know what? It's only point to no. I want to update head to be here, and head down next to be here. So basically swap these two. When next equal to next, head on next is previous. Head on next should point to this. Head on next is equal to previous. And then we return previous. Right? We initialize previous as no. Pre is no. And then because we want the head down next, we want head down next to point to previous. So the new head is here. And then the new previous is here. Right, this is the first loop. And then this, well, so previous is no, and next is head on next. Head on next is previous. Head on next is previous. Previous is no. So head on next is here. Right, and then previous is head. Previous is coming now head. Previous is now head. So this is the new previous. Eraser. So this is now new previous. And then head is now the next. This is the new head. This is the first iteration, right? And then next iteration, head on next equal to previous. This will be the head on next. Right, and then we update previous to be this one. And then the new head will be the next one. Right, this head on next now. And then previous will be this one, and new head is this one. And then we iterate until the previous becomes no. And we return the previous. This BGR reminds you of dating thing. What's dating thing? Oh, this is not fun, It's not fun again. I know there's a background, like sounds weird, but like, there's a background playing, and that's purely for you guys to listen. For me, I don't have background playing. I don't have my headphone on. So I'm trying to simulate like what an interview situation is, because in interview you're not listening to songs, right? Okay, so we reverse this. Let reverse equal to reverse and slow. So now we have a reverse, which is 654. We can stop right now. We can just double check that we have the correct one. So console log reversed. .val. When did I mess up the pronunciation? Reversed. So if we console log, because this is a note, right? This is just a note. If we console log the note, it should return 6. Okay, test case is 2, 4, 6, 8, 10, 12. So if we console log the reversed, the first note in the reverse should be 12. 12, right? So this is correct. Now what we need to do is while reverse dot next. Next is not null. Head is equal to will head dot next. Okay, let next equal to head dot next because we want a placeholder. Next equal to head dot next. And then the new head dot next is gonna equal to the reverse. Remember, the first item in the reverse is 12. So head down next will now equal to the first item in the reverse. Head on next is now reverse. Oh, I think we need a copy of reverse. We need a copy of reverse because we now want 12 to point to 4 instead. So if you look this first, if we look this one time, after we look this one time, this bond next will be pointed to here, and we cannot traverse to the next 10. So we need a copy. Copy of reverse is equal to reverse. My head on next. So we just increment the copy. Copy reverse. Head on next is equal to reverse. Head on next is equal to reversed. And reversed dot next is now equal to next. Is equal to copy reverse. So now we increment both copy reverse dot next. Copy reverse equal to copy reverse dot next. And then wait, do we really need copy? Snow is pointing to net because we are updating. We are actually updating the. Because we are updating the linked list. We updated the nodes in that linked list. And head is equal to head down next. But this is this doesn't sound right. Oh, can I make a new board? Okay. So now head is 1, 2, 3. Reverse is 6, 5, 4. Like this is the head right now, and this is reversed. So this will be the next. So head is gonna point to reverse. Reverse is gonna point on this. So we increment copy reverse. Copy reverse. Next time reverse this node will be pointing to this. So we cannot use this node anymore. So we use copy to increment. And then head we can do head next. So next time we run this, the head will be here. And because we are copying, or in that case we don't need to. Yeah, we don't need to move the reverse. So on the next iterations, 1, 2, 3, 6, 5, 4. Head is here. So I'm updating reverse on next. Or instead of copying here, so head is equal to reverse. We're gonna make a copy. Copy is equal to reverse, equal to current reverse. And head on next is gonna be the reverse, and reverse next is gonna be next. So now we can update reverse. We can reverse the reverse. It sounds very confusing right now, but I don't know how to pronounce. Reverse is now equal to the copy. Dot next. So head next, we just move that. And now this one will just increment reverse. So run. Cannot read property on no, which is next. One of these here is hitting a no. If reverse is not no, oh, because I'm incrementing heads. So when I return heads, is gonna be at this number. Or actually, you know what? Is head on next. It's gonna point to no. So when you return head, the head is gonna be no. So we might need a solid copy of head. New equal to new is reserved. New is a reserved word. Let head 2 equal to head. So in this case, we're just moving head 2. Wait, hold on. It's 101 because if I copy head 2 and return head, if we manipulate head, head is. Wait, hold on. This makes a copy. It makes a copy. It's not a reference. So if we manipulate head. Head 2 will still be the original copy. You see that thing pop out, like how satisfied with your experience? I would be more satisfied if it doesn't pop out like every like 10 minutes asking me how satisfied I am. I feel like those kind of thing is like I would be satisfied if you stop popping up. That kind of deal. A lot of apps has something like that. I just get annoyed. Okay. Probably is the. I believe we have successfully reversed this. However, the problem is that after reverse, the new head is the nose pointing to the end. Like I believe my result is already this, but the problem is the head node is pointing at the end. We need to somehow have the head node to we will. After we reverse this, how do we reset the head? If I do it backwards, because we have a reverse function here. And if I do it backwards and then I reverse the backward, he should update to this. I believe we are up to this point. But how do I reset the head? I make a copy like go to what the head and return head 2. I don't think this is that easy. Wait, hold on, it is that easy. So total 4. Except here is one messed up. We can test where it messed up. Actually, if we start printing out reverse, also logs, reversed, reverse doorbell, and reverse door next doorbell, and reverse door next doorbell. 1, 2, 10, 8, 12, 10, 8, 12, 10, 8. So we know that reverse is working. If reverse is working, then this is one mess up. So next is equal to head on next. We make a copy of the reversed, and then the head on next is now reverse, which is 12. And reversed head on next is reverse, so it's 12. And then 12 used to be pointed to 10, right? So we, instead of pointing to 10, we're gonna point to the head on next. So reverse on next is pointing to the head on next now. Basically, we inserted the first item of the reverse in between the heads and head on next, which is working. And then since the reverse has been updated, reverse on next equal to this. Reverse has been modified though, so we get the copy back. So now reverse is equal to copy. The previous copy is this. So copy dot next will be pointing to 10. So reverse is now at 10. Well, so now we update head is equal to head dot next. Head dot next will be 12, and the head dot next again will be 4. Oh, I see why. So it's now at 4. So the next run, next is equal to head on next, which is safe. Oh, okay. So is it a head on next on next? We can do this. So run. Infinite loop. Basically it skipped the 4. After 4 it should be 10, it skipped the 10. So right, then now head is 4. So 4 dot next is 6. Copy reverse, and head dot next is equal to reversed. Head dot next. Head dot 4 next is 6. And reverse next. Reverse dot next. Okay, 1, 2, 3. Reverse is 6, 5, 4. next, head, reverse. Head down next is reversed. Head down next. Head down next is pointed to this. And reverse down next is equal to next. Reverse down next is equal to this. And we update the reverse. We update the reverse to the copy of the reverse. Copy of reverse is here. And then we move the head to be head on next, head on next. But after these iterations, it will be 1, 2, 3, 6, 5, 4. This is the head now. This is the reverse. Right, next equal to head on next. This will be the next. And head on next equal to reverse. Head on next. Head on next is gonna be equal to reverse. And reverse on next. Reverse on next is gonna point to next. Head on next. Because this is a copy of next, so reverse on next is gonna point to this. And then we update reverse. We update the reverse from the copy. We copied this part. So the copy is at 5. And then we update reverse to the copy dot next. 5 dot next is 4. So the copy reverse will be now at 4. Yeah, so second iteration was to be correct. Why is it not correct? Why? Why? This problem shares similarities with parent join linked list. To rearrange the given linked list, we will follow the following steps. We can use fast and slow pointer method similar to middle of the linked list to find the middle node. And that's what I did. Once we have found the middle of the linked list, we reverse the second half of the linked list. That's what I did. Okay, finally we will iterate through the first half and reverse the second half. And the reverse second half to put this linked list in the... This is what I tried to do. Use video representation. Okay, so thing fast that this part we can understand. So by the time fast hits the node, the slow will be at the middle, right? And then we're gonna take the middle, and then instead of head pointing here, we're gonna set a previous, and then have the next, and then have the head on next point to previous, and the head point to the head on next. And then go to the next one and have the previous point to the previous head on next, and then head on next. So previous point to head on next point to this, and head point to the next one. And by the time you return, once this hits null, right? The previous would be the previous will be at the... So on the next iteration, previous will set to here. And because this head will be no, so we exit out. After we exit out, we return previous. Previous will be 12. Alright, so by the time it's done, so you set previous to no, head is here, next is here. And then you set previous to here, and then you head is here, next is here. And then you set previous here, head is here. So by the time you're done, you just read me. This becomes like this. Points to this. Okay, now how do you insert? Initialized head first is pointed to the head itself. Okay, the head is pointed to here, and reverse is pointed to here. Insert 12 after 2. So first half down next equal to second half. And then you update. Well, you have a placeholder called first half. You set placeholder, you set it to 4. And you have this point to 12 and have 12 point to 4. And then you update the copy to update the placeholder to be 6. So have the first half point to 10, and then 10 point to the updated copy. Yeah, that's what I'm doing. Like after this is done, it becomes like this. The new head will be here. So, with this edge case, slow is head, fast is head, while fast is not no, fast on next is not no. This is what I did. And then they reverse this, right? They reverse this by doing this. This is what I did. And then they first half, or you make a first half and copy. Make the first half and copy it. First half and copy the head. So now instead of doing head, we can do first half. And return head. But return this. 6. It's still like this. First half. So you reverse this. This will be the second half reversed. First half you make a copy of the head. If her first half is not null and second half is not null, so you make a placeholder and hold the next. Right. So next is gonna be the second half, and first half gonna be the 10th. First half will be the next. And then 10 is equal to second half. now reuse the temp. Temp is equal to second half on next. Okay, so this one, take 1, 2, 3, 6, 5, 4 example. Temp is now pointing to 2. One dot next is pointed to 6. And then you update the first half to 2. Oh, this is pointing to 6. 6 is not pointing to anything. So you make a temp again. Temp is equal to 6. 6 dot next. 6 dot next is now 6 dot next is 5. And 6 dot next. And you update 6 dot next to point to the first half. First half is now at 2. So now 5 points to 2. And then you update the second half to be 5. Okay, I see. So in that case, then you don't need to use copy. Alright. Scratch this. So we want reverse to be not null, and first half is also not equal to null. So we first make a temp equal to first half. So we make a placeholder for first half dot next. So first half dot next should now point to reverse. And then we update first half now to temps. So next, we're gonna update the second half, which is the reverse. Temp is equal to reverse. It's kind of reverse is not. We have not updated reverse yet. So reverse dot next, we have temp equal to reverse dot next, and then reverse dot next should now point to the first half, because this is already incremented. Because this is equal to temp, which is the first half dot next. So reverse dot next equal to the first half, which is the first half dot next. And then we're gonna reset reverse to temp, which is reverse dot next. So we're not doing that. And then last we return head. Cycle detecting, no? Wait, cycle detecting, no? Should I go? We do that until we hit, until there's no next anymore. Okay. Submit, okay? Yes. Oh my goodness. Look at this thing. Look at this thing. How satisfied? How satisfied are you with your experience? Right? If you stop popping up, I would be more satisfied if this stop popping up every 10 minutes, and asking me how satisfied. No, I'm not satisfied. Stop popping up. I would be satisfied if it doesn't pop out. Every time it pops out, I click X to close it, and then it pops out again. How satisfied are you? I don't want to answer this question. X, and then it pops out again. How satisfied are you? I do not want to answer this question, so now I'm not satisfied. Oh my god. Anyways, I would say I managed to do 90% of this question, with the other 10% I cheated. Cool. You see, this pops up again. They see me coding, they're hating. Why do you hate coding? Coding gives you money. Although this is not coding, this is more just this is more like algorithm challenge. This is more like algorithm challenge than actually coding in real life. There's a difference. Next one is hard question. I don't even wanna bother with, because I already fucked up my brain. Problem challenge: cycle in a circular array. We are giving an array containing positive and negative numbers. Suppose that the array contains a number m at a particular index. Now, if m is positive, we will move forward n indices, and if m is negative, we move backward m indices. You should assume that the array is circular, which means two things. If we move forwards, we reach the end of the array. While moving forward, we reach the end of the array. We will jump to the first element to continue the movement. Oh, okay. If we move backward, we reach the beginning of the array. Then we will jump to the last element to continue the movement. Write the method that determines if an array has a cycle. The cycle should have more than one element and should follow one direction, which means the cycle should not contain both forward and backward movements. It's only one direction. Well, welcome to problems that designed to fuck up your brain. Write a method determining if the array has a cycle. The cycle should have more than one element and should follow one direction, which means cycle should not contain both forward and backward movement. Input is true. The array has a cycle. Yours 0, 1, 3, 0. Index 1. Index 1 means you move forward 1. And then 2 means you move forward 2. And then 2 you means move forward 2, which is 1 again. And then 1 side you move forward 1. Okay, so that means it's a cycle. This is true because 131. What do you mean 131? You start with 2, right? You start with 2. 2 says you move forward -1. 2 says you move forward 2. And -1 says you move back 1 time. And 2 says you move forward 2. And then 2 says you move forward 2. And 2 says you move forward 2. And 2 says you move forward 2. 2. So it's a cycle. Okay. The array does not have any cycle. So 2 says you move forward 1. And then 1 says you go back 1. You go back 1, and then 1 says you go forward 1, and -1 says you go back, and 1 says you go forward, and -1 says you go back, and 1 says you go forward, and -1 says you go back, and 1 says you go forward, and -1 says you go back, and 1 says you go forward. It's an infinite loop. This is not a cycle because this is a backward and forwards. They will only accept a cycle which is only going forwards or only going backwards. Okay, got it. Got it. Welcome to programming problems you won't likely facing any actual programming job. In fact, I would say 99% of the programming problems that the interviews give you, 99% of them you won't see them in actual job. Okay, we can do slow and fast because slow and fast we can detect a cycle if the fast hits the slow, and that's easy. However, the precondition is that between fast and slow hitting, they must be moving the same direction. That is a problem. How about if we detect a cycle, we run the cycle 2 times? The first time to record the direction, and then the second time to record the... Actually not. Okay, the first time to record that, okay, there is a cycle going on. And then the second time we just record, within the cycle we record the direction. I think that would be easy. Okay, let's do that. So we have an array. We're gonna set a fast and we're gonna set a slow pointer to be index 1. A fast pointer to also be index 1. Not me. Fast slow pointer to be index 0. While fast we're gonna move both our pointers. Hello. The correct answer to any interview questions is to not answer any questions because they are not relevant to work. Exactly, but that's how you not get a job nowadays. Even though it's technically correct, but you won't get a job that way. Then even Yu-Gi-Oh is much easier than this. I think in this case, do while is fine. Do? Wait, while low is not equal to fast. What we're gonna do is we're gonna create a separate function called determine the movement, and then we're gonna pass the index. Okay, after we pass in the index, if index is a possible number, then we move the index to the right. So let's move equal to index plus index. Oh, we don't know. I don't care about that right now. Index plus array dot index, right? If we move it's out of bound. If we move the index is out of bound, then okay, guys, see this going up. I'm gonna make it bigger, even bigger now. Okay, if we move, it's outside of the index of array. So array dot length. So if move is greater than array dot length, actually this could be negative number. So if move is greater or move is less than 0, right? We're gonna update move. We're gonna update move to be left absolute value of move minus array dot length. It should be while, because they could because array I could be 1,000, right? So you could move 99, you could move 1,000 times, and if the array is like 2, so you can move out of bound like 500 times. So that's why we do while we do a math absolute and then move minus array dot length. And then if the move is still greater than or less than, we're gonna keep doing absolute, because it's gonna keep moving out of bound until we arrive at, I believe this should be array dot length is fine, yeah. Move is array dot length. Then we return move. Then this will be the new index, right? So slow is equal to movement, and then we passing in slow. And then fast is equal to movement of movement fast, right? So eventually, if these two meet, then we found a cycle. Okay, after we found the cycles, the next one we want to determine is we're gonna continue to move this in this cycle, but in this case we want to determine the direction of the movement. So the move here must be either negative or positive. I mean not both. I mean this index should either be positive or negative. So if we restrict the movement to be one direction, we can do this one more time. And then the second time when we do it, we're gonna set a direction. If we move them forward, then all the indexes that returned should be a positive number. But in this case, we can set a left forwards equal to true for now. If array dot slow actually, you know what? Array slow is greater than 0. If it's true, because we want the entire loop to going forward, either going forward or backward, right? So it doesn't. So we can initialize the first value to be the first item. If first item is moving forward, then everything else follows should be moving forwards. And if the first item is moving backwards, so everything in the loop should be moving backwards. Alright, so array slow is greater than 0. If it's greater than 0, then it's moving forward, so we set it to true. Otherwise, we set it to false. Right, and then we keep doing this. If is there any method that actually, you know what? If the current slow, because this already moved one time, it's already moved one time. If this current slow is equal to greater than 0, is equal to forwards. If forward is true, we want them to all be equal to 0. Actually, we want it to, if it's not equal, then we return false. And then we return true here. You see here, I'm such a genius. So, the first item, after we found a cycle, so within this cycle, we want the cycle to be all positive number or all negative number. We can determine that by looking at the first number. If it's positive, we set it to forward to true, right? So and then we do this cycle again, one more time. And each time after we move, after we done a movement, we look at this again. We look at the index of the value. If it's greater than 0, greater than 0, right? We want them to be all equal, so we want this all to be all true. And if it's false, then we want them to all be false, right? So once it's not true, once this condition not satisfied, then we found a index. We found a value from the index that's different than the value from other index within the circle. That's the opposite direction of the cycle. So then we return false. Alright, so this should be like this. And then there's an infinite loop. Oh, I haven't taken into account of infinite loop. Okay, this will find an infinite loop because this can be forward and backward. This finds a cycle. But what if we don't find a cycle? What happens if we don't find a cycle? That's not possible because there's no ends. There's no end within here. So eventually we will hit one of these number again. So this will eventually meet. What about movement? Also log don't move. No, because if this is a negative number... Actually, if move is negative number, we keep adding negative number. Actually, no. If this is a positive number... If this is a negative number, then we keep adding the negative here. So math.absolute, we are not doing minus. So we math.diff. Is it diff? Yes, math diff. Return math absolute is minus. So it's still the same. Math absolute move minus array dot length. If I console log don't move, they should be all different values. If it's empty. Move is empty. Why? Move is empty, so it never went to movement. How do we start a infinite loop without even going to the loop? Movement slow, index is slow, index equal to array, index is 0. Oh, because this never went out of bound. Array index is 0, index 0, 0 plus 1 is 1, return 1. So this return 1 and then we move 1 again. Passing in 1. 1 plus. Oh, this is not plus. It's just a index. Array don't index. You just move 2, right? I think no. Yeah, it is index plus. Well, slow is at 1. Wait, this is 2. You move 2 ahead, so it will be 1 plus 2. You'll be at 2. I mean, 1 plus 2 is 3. So you move to the index 3. Index 3. And then we loop this again. Movement of index 3. Index 3. So 3 plus index of 3 is 2, which is 5. 5 is greater than array.length. 5 is greater than or equal to. The move is 5. Index of this is also 5. So they're equal. It's greater than less than, we do this. If move is equal to array.index, array.length, then we set the move to be 0, index 0, if it's equal to the length. So run this again. Yes! Yes, okay, so the whole problem was that we're hitting the... We should hit out of bound, like we found the last value to the next index, so it was supposed to be reverted back to here. If I submit this, wrong. Use example test case run. Oh, so it's all true. All true. Look, I'm so genius. But this is false. Run false. Output is true. Okay, so 3 is here. And then 5. 1, 2, 3, or 5. 5 will be at 5. 5, 5, 5, 5, 5, 5. So it keeps going 5. So it should be true then. Shouldn't it be true? Yeah, my thing is correct. So 5 moves forward 5, and because this array only has 5 items, so if it moves forward 5, that means it will land on itself, right? So if it lands on itself, so it only moves forward 5, and it's a cycle. It should be a cycle, right? If the cycle is only move forward 5. It's a cycle! What's wrong with this? They expect first. Oh my god. So we don't want the cycle to be only one item. We don't want the cycle to be only one item. Or in that case, we can count the length of the cycle. We can do a count on the length of the cycle. Let count equal to 0. and each time we move this, we increment the count. And if we don't detect a reverse direction, and if count is only 1, then we also return false. Oh wait. Yes! Oh my god, I beat the hard questions. I beat the hard question by myself. I'm so smart. Hey chat, I'm so smart. Next. They probably involves finding a cycle. Fast forward is an effective way to do that. We can start from each index. And if a number does not have cycle, we move for our next element. There's a couple additional things we need to take care of. As mentioned in the problem, the cycle should have more than one element. This means that when we move forward, when we move a pointer, if the pointer points to the same element after moved, we have one cycle, therefore we can finish our cycle. The other requirement mentioned in the problem is that the cycle could not contain forward backward. We will handle this by remembering the directions. Yeah, that's what I did. Your number is positive, then we do this. Fast, slow, fast, slow, fast, slow, fast. Oh, I guess that's easier. So what I did was that in my question I did a while loop, and within the while loops, we do math absolutes. And the movement minus the radar length, right? So we can actually just do the movement, mods at radar length. We could just have done that. But anyway, that's only difference. You see, they also did the forwards. Is forward to be greater than or equal to 0. In this case, they include 0, but 0 is not moving at all. Why choose you find it next? Okay, they also made a function to call find index. So that's the same thing. You find index if fast is no -1. Oh, they're also passing is it forward or not. Oh, so they calculate is forward or not. So what I do is I first find the cycle, and then we loop, and then find the directions. But in that case, they also passing in these to handle the direction. So they handle the directions while finding next. So if the direction is false, If there's a change in the directions, then you return -1. If it's -1, then that means it's a change in direction. If there's a change in direction and you move fast by 1 more, oh my god. If there's a change in direction, you move faster by 1 more. And if both fast and slow is moving on the same direction, then you break it off. If slow is not -1 and slow is equal to fast, then it's true. Anyways, it's the same logic. Same logic, just written different way. Hooray, we are next. Next problem set, sliding windows. And I will do it next time. Yeah, I need a break now. I need a break, so I'm gonna schedule a method duel. Probably, I'm gonna schedule one that's like an hour after this. So let me see. Schedule the use settings. Good brain chaining. No, this fucks your brain. I'm pretty sure this fucks your brain. Well, I'm gonna take this value that I have. I'll take a previous link that I have. Copy. Paste. And then I can update the title. The title will be Top 10 Rated Duo White Force. Like next. And the time will be 10:30 AM in my time. Done. And then I can copy and go to the current life, which is you guys. Here's the new here's the new here's the new here's the new life schedule that you guys can subscribe. Anyways, I'm gonna end this now and then I'll come back later. Bye bye. 知心当初有多么激励，如今摸着胸口就都冷冰冰。数一数身上寄出淤青，还剩多少故事可说，证明我也曾经叛逆过，我也曾经离家出走。